Good afternoon, everybody. Thank you for joining this session. Before I start, maybe I will make a poll and ask who actually have heard about DOH. This is abbreviation of DNS over HTTPS. Can you raise your hand? Oh, I see many hands. Great. So last year, also October, major browser vendors, they announced that they will be including this new feature for encrypting DNS traffic. So a year has passed, and we have, in NIC, we have also implemented and have our observations about the technology, our contemplations, and we wanted to share those observations with you. And so first of all, a little bit about DNS. That's the core domain name system. That's the core protocol and system of the internet. And it's a big distributed database. So whenever we humans, we are good at remembering names, and when we want to get to the resource, we usually enter some name in the browser or some other program. And DNS, this is called DNS resolution. So we translate the name into an IP address, which in turn is used by the system to connect and deliver the data to you. And what is the problem with that, with this communication? Since the very beginning of the design of this protocol, it runs in plain text. So there are no real, so we see those, we can see those requests on the network. Any passive observer on the network could wiretap and see these packets and see that somebody is requesting some kind of resource, and he also received some kind of answer. And if somebody would capture large amount of data, we could call it big data, and then analyze, it might end into the privacy issues, because they could analyze each individual habits, they could see what we are interested in, what pages we are looking at. So, and luckily, there are two protocols which are bringing us possibility to encrypt DNS data, and there is another one. So I was announcing DOH, and there is another one which is called DOT. It's DNS over TLS. In other words, it's DNS over HTTPS, and these are kind of protocols which are now competing with each other, because DOH is a software side implementation on a software level for communication, and DOT is more on a transport level, stays on TCP, and uses the native DNS for native DNS resolution, and for both of them that runs on TLS encrypted communication. The difference is that DOT needs a new port introduced, which is 853. The regular port is 53. So this means that outgoing traffic in firewalls would need to open this new port. So, which is not the case with DOH. So DOH is more lucky with that, because they will be using port 443. And that's why they use the port for secure web communication. And the benefit of DOT is that it provides instantly encryption for whole operating system, not only for one application. And on contrary, for DOH, its DNS's resolution is only happening on the from the specific application. So if it's implemented in a Firefox, then only Firefox will use that. And important thing is that this application would circumvent, it will bypass the operating system resolver. So it will be talking directly to the name server, which is not configured in your system, but will be talking to the name server, which is configured by the software vendor. Or maybe software vendor allowed you to specify other DNS server. So that's a huge difference now. And I think that looking at the current software implementations, it seems that DOH promotes more of the DNS traffic concentration, which is a problem. We'll look into that later slides. So if you want more information about, there is a standards for both RFCs. But okay, if you're still following me, then okay, I called the legacy DNS, which is actually we are currently using. So with the red arrows, there is unencrypted traffic here. Application, in this case, is using a system call to the operating system to get a resolution of the domain name to the IP address. And then this information travels unencrypted to the recursive resolver, which in turn asks all over the world for to get the information for requester. So that's all unencrypted. With DOT and DOH, we can secure this part. Both brings in the security level at this side. Still, we think the industry has to come up with something to secure this from your resolver to the root server, to the COM zones, etc. There is a protocol called the RFC for queue name minimization, which would increase the privacy so that the resolver doesn't disclose immediately whole address you requested, but it discloses only a part of it. So it asks only where is the LV domain name servers located, and then it contacts to the LV domain name servers and asks specifically for NIC, and then after that it might ask only specific host name. What's interesting, as I said before, though, is circumventing the operating system. So there is a certain issues with that. We'll talk about that in the next slides. And to confuse you completely, I have to mention also there is another protocol called DNSSEC. Those are this is also DNS security extensions, and we implemented that for LV zone in 2012. Since then, we had several workshops going on, and we were talking about DNSSEC, and somebody asked me, hey, that's great, now my DNS traffic is encrypted. I said, oh no, it's not. DNSSEC is not providing encryption. It's only for the signing of the reply, so that you have the integrity of the data. DOH and DOT doesn't replace DNSSEC. We need either DOH or DOT and DNSSEC to work together. So DNSSEC is for integrity, and DOT and DOH is for confidentiality. So both these work in the same system. So more about DOH problems. Since it's I'll show a few screenshots later why it might get consolidated in hands of few. That's really up to the software vendor if it doesn't allow flexible way or it has some default values, which most probably users would never change. Yes, and if there are some default values pointing to some specific provider, then most probably all the traffic of, for example, if that's a browser, would go to that particular provider, and I think it's not a good idea. So since it's also circumvents the local settings for your resolver and doesn't call your resolver, for example, in your enterprise, you may have also internal domains or special split domain configurations where you see only your internal resources, and on outside you see outside resources. But in this case, if your resolver is skipped, your browser will not be able to open those internal pages. So also it would skip any filtering if you have any protection systems in your enterprise or in your solutions. It will ignore etc hosts if you have a Linux system, and the same is for Windows. If you specify something in host file, it will be ignored. And it could fool the content delivery networks as well, depending on which provider on DOH you are using. If they are far away from you, and CDN, the content delivery network discovery is based on the DNS close to you, then they might think that you are in a different country. So the streaming experience of the video or something might reduce because of that. They will probably think that you are not in Latvia, for example. So about browsers, I really like Chrome's approach for now. I don't know how it's all in development stage, but from the version 78, I think it's coming out this month or at the end of this month, and they will start experiment with the DOH auto upgrade, and they will, from what I've heard, they will start upgrade on these 6 providers if you have them configured in your system. So it's not a big issue for the what I previously mentioned about the controlling all the traffic in hands of you. But they will test if you're using any of these providers, then they will upgrade also your browser. That seems logic. Another case is when you have browser, maybe also in a testing stage, maybe they are covering only different regions for the starter. But the default value is only a single provider. This means if you are enabling that in Latvia, then your DNS traffic will terminate to this provider and maybe goes overseas, all your data. We don't know if they collect or not. So I think if there is a possibility, then we shouldn't exclude that fact. So but the browser allows you to configure something specific. There's an example of NIC.LV server, but you can use your own server if you develop one. Now this is information about NIC recursive resolver. We have a long history of this resolver. We started since dial-up times, so it was a necessary infrastructure for internet to work. And at the time, connections were very slow. We had a good connection to international connection, so we were giving this service to the Latvia community to use. And this was for free, so everybody still can use. It's free of service. And over time, when we noticed that there are appearing more of these cloud resolvers with quad names, of course this address is not so easy to remember. It's easier to see if all 4 numbers are the same, then it's easier to type in the configuration. But we didn't like the idea that all the traffic suddenly goes only to these remembered numbers. So, but therefore we improved our server over time. We introduced anycasting where you have the same IP address distributed in multiple locations, so that there is a resilience of the service. We also have DNSSEC validation, which protects if there are some invalid answers from or fake answers from the source. And We also have introduced CERT.LV firewall. This is a kind of blocking, which I don't like the blocking myself, but this is a little bit different because it's not the blocking as usually legislation would say, we need to block gambling or something like that. This is different because it blocks resources where usually humans don't intend to visit. So you wouldn't even not notice that, but if you, for some reason, hit that resource, most likely it's malicious resource and it would do a harm. And what's good about this CERT firewall, because it's built from the events happening here in Latvia. So if there is a campaign going on geographically, so we can quickly react and update with the latest malware events or campaigns we see. And of course, no log stashing, like everybody else is claiming. We do a logging if we have a problem. We need that, but otherwise we don't, since it's we don't save it on disk, and we never, over these 25 years, never monetized it. So no data sharing with and abuse. So if we compare of the workload, we invested on each just for you to, if your organization is going to implement that. For us, it took about 150 man-hours combined. It's much easier to implement. So, when we talk about security, so I mentioned encryption. I just wanted to give you food for thought that not always when we say there is an encryption in place and I'm secure. That's not always the case. And I'll show you a few examples. The other factors, actually, who leaks almost the same information that we just protected with the encryption of the DNS traffic. So, for example, TLS name, server name indication. So it's called TLS SNI for abbreviation. And the browser usually sends this server name indication to the server to indicate, okay, that I will be connecting to this particular resource. Because one IP address can serve many pages, but it says I will be talking to this particular page, and I will be establishing a secure connection. Before this secure connection is established, the conversation happens to be in plain text. And therefore, I'll have a little video about that. And next is online certificate status checking. There's a protocol, OCSP, which is designed for checking whether the certificate state has changed. For example, certificate might be revoked, and the browser, when it's connecting to the resource, in the background also checks whether the certificate is still valid, because it could be valid in the website, but it's revoked a while ago. So there is another request going on in a net wire, which is unencrypted. Then TLS assumption. This is designed for optimizing TLS transport layer security connections, because initiating an encrypted connection is expensive, and resumption is done so that you have the server saves a session and client side saves a session. And if these sessions, the server compares the sessions, if it matches, it lets you in. And the same as there are resumption tickets, the similar technique. And another issue is the application UI and user experience. Whenever you say that you will be encrypting, the traffic, you need to stick to that. Otherwise, and if you don't have the indication that there is no more encryption, you have to inform the user. And finally, the IP address itself. If you connect to the IP address, it still gives potential observer information that you were connecting to this IP address and probably interested in this resource. So just keep that in mind. So there is a short demonstration. I'm using Tshark to capture TLS session, so encrypted sessions beginning. And I will be opening a news site because it's quite loud on network. So and it gathers already here. This is encrypted, but still it gathers information from the sites I was visited. So TLS resumption, there's a task for you. I don't know if you can see that, but does anybody see anything interesting here? So these are two captures, network captures, and encrypted sessions. And anything interesting? Okay, I'll help you. So this was the first session and the second session. As you see, the session ID is the same in both sessions. And what's different, the server is the same, but the client side connected from the new IP address, it was one location, another location. And here we have even here the session uses previously negotiated keys, which is cryptographically sound. It's fine, but still observer, on the passive observer, can see that I was connecting from two different locations with TLS session, which is matching session ID. So they can correlate that, okay, I was the same guy who was visiting these different resources. I forgot to mention that this was not this was from University of Hamburg. You can look later for this nice white paper. So tracking users across the web via TLS session resumption. Yes, but I think if we look at this problem on a DNS, it's even a bigger issue, because then we don't re-establish our connection to multiple web pages, but in DOH case we establish connections only to a single server. This means we have persistent connection which all the time, which could be extended and extended, and there could be continuous tracking. So just to think about. Application user experience. We set, for example, default settings here proposed by the browser, and there is a TRR mode. This is specific configuration which says it allows to fall back to the to the operating system name server. And I captured the request to my name server here that the IP address will match Cloudflare, and I will be blocking, for example, if network operator blocks the traffic to the Cloudflare on a firewall, and I make another request, that packet gets to the Cloudflare, gets dropped, and I can see that my name server received now a request from another server, which is the operating system server. In this case, the traffic wasn't encrypted, but I didn't see any notification on the browser. So I downgraded from decryption to plain text, but no notification about that. So the summary is that we need to encrypt. Encryption is good. We need to avoid traffic consolidation in the hands of few. And there is a lot of work ahead to improve other protocols if we want to achieve the privacy. So Thank you, and I'm ready for questions, if any.
Are there any questions?
I'm Varis with CERT.LV. What do you think should be done in the European level or maybe on a country level to somehow protect the information of their citizens, as I assume it might leak to foreign states in that case?
Well, so as a provider, so like ISPs, we have to, since this is a good initiative by the browser vendors, I think, because we need to do the encryption, because if you look back at the other protocols, like DNSSEC, it was, I think, standardized in 2005, and then it took many years to introduce. It's a complex protocol, but still, if we compare. But this time, I think it was a driver also for us to react on that, because we don't want really that our traffic of Latvia goes away somewhere. And I think every ISPs and also internally in enterprises, we need to bring up our own DNS servers supporting that function. And I don't mind maybe if, for example, Spotify application like music streaming would use their own DNS server, which is hard-coded inside the application. But I think the browser is the different case, because it's not like streaming application would connect only to the music servers the company owns, but the browser is a different case. It's a viewer which I'm using to view other resources which are not related to the browser vendor.
One side note as well. I have heard some rumors that at least one country has requested an exclusion. That
the UK.
Yeah. So if that goes well for them, then possibly that might be the right approach. That the users are not using it mandatory, but it's off by default. Or how do you think?
I think it's for the browser specifically. I think it's this provisioning part should be done very slow and clever, so that it upgrades to the existing infrastructure name servers. That's my opinion. That's what I would approve. Yeah.
Thank you.
Okay, thank you.
I do have a question. If considering corporate environment, you do have some intercepting proxies, what possibilities do you have to play with those DNS, HTTP DNS requests or and replies?
It depends. So if it validates against the TLS session validates against the CAs in the browser, I think you still can, in the enterprise, you can introduce your own CA, and then the firewall has your own CA, and then it will be able still to filter those requests, even if you don't have your own name server. But I think the best approach would be to just to provision with your doc server or dot server.
And then for the private individuals, this TLS session tracking sounded like really scary. Would it actually be recommendable to the individuals to use it, or it will kind of create more harm than benefit?
It's what I said. It's just food for thought. We decide how we configure our systems, but it's more scary because now when I travel, I don't use the local resolver in that country, or for example in this conference. My computer, if it's connected to the DOH, it will always use that particular server, regardless of my location. So it's a static configuration right now. So the legacy system, if we can call it, the current system, is that whenever I change the network, for example, if it's DHCP, so dynamically I receive new information about my name servers in that network, and I think it's more distributed. So if somebody globally tracks you, then it's not so easy. But if you are connected to one particular server during all your sessions or travels, then it's sounds scary. Yeah.